So, what do you guys think of when you think of an inequality? Symbols or anything like that, anything come to mind if I say inequality? Yeah. Yeah, like, okay. So, the major inequality symbols, you've got like a greater than or equal to, less than or equal to. And we're not really going to use this today, but that symbol I gave you guys for the restrictions, for what we were working on with our restrictions and our literal equations, not equal to is actually an inequality, because an inequality just means not equal to. Okay, now solution of an inequality can be, it could be that it doesn't have a solution, that would be a special case, could be all real numbers, or the one we're mostly going to see today is going to be a range of numbers. So if I say to you, like, I want all the numbers greater than or equal to 75, there's a lot of numbers that would fall into that category. And we're going to talk about today how to label that and how we're going to have some notation that I don't know if you guys will know or not. So that's what we're going to do in this very first step. I just have 4 inequality graphs. And I'm going to see if you guys could give me the inequality notation. I'll have us use x. So like x is greater than or x is less than or something like that to describe the graph. And then I don't know if you guys are going to know the interval notation. So we'll go over that here together in a second. Okay, could anybody write me or tell me how to write an inequality just for this first picture? So I've got a number line. This is supposed to be a filled in circle at -2 with an arrow across the number line that points to the right. Yeah. Perfect. X greater than or equal to -2. I always remember if the circle is filled in, if you see it, it's solid, so it's greater than or equal to, that inequality symbol is going to be underlined if it's filled in. Just means -2 is part of our solution, and then any number bigger than that. Okay. Has anybody in here ever seen interval notation for an inequality? It has like brackets and parentheses? No, maybe. Okay, I'll just do this first one. Okay, so whenever you do interval notation, you start with the smallest possible value. For this graph, the smallest possible value we can have as part of our solution is -2. Okay, now, as I do, they're going to have grouping symbol around it. If it's a solid circle, means I touch that point, then you put a little bracket. It looks like a rectangle that you just draw half of a rectangle basically, but it's a hard edge little side. That's a bracket. That means we actually touch that number. And then you're just going to put a comma. And this is a little bit trickier part. The other part of the interval notation is the biggest possible value that you could have. So since that points to the right forever, does anybody know what I would put next to the -2? Infinite, yeah. You're just going to put an infinity symbol. Exactly. All right, now, infinity is not a specific number because I can keep adding 1 every time and get bigger, bigger, bigger. So this never has a bracket with an infinity symbol. You're just going to use a parenthesis because you don't actually touch infinity. We can always get a bigger number by adding 1 to any number. So parentheses always around an infinity symbol. Okay, can anybody help me out with the inequality for the second picture I've got for this number line? Could you write an inequality for that? Perfect. X is greater than 0. Okay, now the only difference between this one and the one we just did for the interval notation, the smallest number I have is 0. If you have an open circle, we don't actually touch 0. So the only difference is you just use a parenthesis instead of a bracket. Otherwise, it's going to be a similar format, goes to the right forever. So the range of numbers we're going to use here is from 0. Any number from 0 to positive infinity would be a solution to that inequality. Okay, who can help me write an inequality for the third lovely number line we've got in this example at the top? Would you write that? Yeah. Perfect. X is less than or equal to 3. Okay. Anybody want to try how you would write the interval?
I wrote opening parentheses, infinity, comma, 3.
Perfect. Okay, I'm going to make one tiny alteration to that. Does anybody know what I'm going to alter? You're just going to put a little negative symbol. That's all it is. Literally, that's it. It goes to the left forever. So the smallest possible number we could have for our answer, we don't actually know what it is because it would go to negative infinity, but that is what we should start the interval with, and then you just stop it with the 3. And since the 3 has a filled-in circle, it has a bracket. So any number 3 and smaller is going to work there. Okay, I have one last one. What would you write down for your inequality for this last graph that we've got? X is less than 1. Sweet. Okay. Anybody want to try the interval for that one? Could you write that with an interval notation? Perfect. Okay, is anybody having a question so far? Okay, we're just going to walk through a couple inequalities to solve. So I'm not giving you a graph. I'm actually going to ask you to create a graph for the solution for these, and then we're going to practice writing that inequality and interval notation. So we're just going to solve this. I'm going to try and get n by itself on one side of the inequality symbol. So anybody want to walk me through, like, how would you solve that first problem in that first example? Yeah. Distribute, okay. All right, so we get 6n plus 2 plus 22. Then what do you want to do? Would you maybe put those together first? Okay. I would maybe just, yeah, combine like terms there. All right, so then we're going to move the 24, right? All right, so I got, what is that, negative 12, greater than or equal to 6n. Okay, what do you want to do to finish that up? Okay. All right, do I need to flip a sign over or anything? No, oh no. People automatically see the negative number and they're like, let's flip this sign. No, we're not going to flip. Go ahead.
Well, if I were to do differently and get negative 6n equals a number, I would flip the sign since I'm dividing by negative number.
Exactly. If your result is negative, that doesn't mean you flip the symbol. Our action here is to divide by a positive 6, so don't flip any signs over. It's okay that this is a negative. Don't just see the negative. I feel like people get so trapped into that. They see a negative and they just want to flip the sign over. Only do that if you are multiplying or dividing by a negative number, which we did not do here. Okay, now, just a teeny tiny recommendation. You can take it or leave it. Okay, if you guys have an inequality, just a variable related to a number like I do here, if the variable is on the left, which it's not here, it's on the right, so I'm not flipping anything. I'm going to rewrite this inequality just so the variable's on the left, just real quick so you guys can see it. So the little part points towards the end, so I'm not changing this, I'm just rearranging it just to give you a little help. Okay, if you have a variable on the left, and you have to graph your solution. This is going to say n is less than or equal to negative 2. If the variable is on the left, and we do not have to draw some elaborate number line, okay, just give me a couple values maybe around the negative 2. So maybe like one number that's bigger and one number that's smaller. And anything that is less than points to the left. The reason I turn this around for you, should I have an open circle or closed circle here? I should have asked that. Closed, right? Okay, now less than goes to the left. The reason I say this to you, if your variable's on the left, you can point your arrow the same direction that the inequality symbol points. But the variable has to be on the left for you to do that. Just if it helps, because some people get tripped up and they're not sure. Now, if you're just reading it, less than points to the left, greater than goes to the right. And then I'm just going to write the interval notation before I go to the next question. What would you guys write for your interval notation for that one? Anybody feeling comfortable with it? So any number smaller than negative 2.
Parentheses, negative, and then negative 2.
Perfect. Is anybody having a question about the interval notation? We use that a ton as we go through the year, so we're just kind of introducing it here a little bit. Okay, Somebody help me out with how you would solve. Let's see, our next inequality, I've got 6 minus 5 times 2 plus x is less than 41. What would you do here? I'm going to try and get x by itself on one side of that inequality symbol. Yeah. Distribute negative? Okay. All right, so I got, what, 6 minus 10 minus 5x? And then maybe I would just combine my like terms. I can put the 6 and the negative 10 together, just plain numbers there, right? So that would be negative 4 minus 5x is less than 41. Okay, what do you want to do from there? Add 4. Okay. Yeah, if you can, get rid of any addition or subtraction before you do any multiplication or division. All right, what do I want to do as my next step? If I'm trying to get x alone on one side of that inequality. Yes. Now, dividing by a negative, so divide or multiply by a negative, you do have to flip that sign over. So now this is going to become x is greater than negative 9. Does anybody have it? Okay, again, if you're doing a number line, it doesn't have to be spaced out perfectly or anything. You don't need a ruler or anything. Just maybe give me the number that's the critical number here, which would be negative 9. Maybe a number that's a little bigger and a number that's a little smaller, just so I know you know where you're at on the number line. And then my variable's already on the left here. So it says x is greater than is going to point to the right. Should have an open circle, right? Because it's just a greater than. So negative 9 is not included in our solution. And then this arrow points to the right. My arrow on my number line is going to point to the right as well. Is anybody having a question? Okay, how would you write your interval notation for this example? What would it look like? Yeah, and infinities always have parentheses. They never have a bracket. So, anybody having a question? All right. Now, I have 2 situations down here. These are kind of what I would call a special case. Remember I mentioned at the top you could have all real numbers or no solution to an inequality. So I just wanted to show you what that might look like if you were working with that algebraically. Okay, I'm just going to do these real quick. I'm going to distribute this 7 here real quick. We've got 7x is greater than or equal to 14 plus 7x. Now, normally, if I'm solving an equation or inequality, I try to get all my like terms on one side. So if this was me, I would probably subtract this 7x from both sides. And what's going to end up happening in that scenario is it actually cancels out on both sides. But it still exists. Like, what would you write on the left side of what I wrote down there? Like, what would you write? 0. Okay, now that's only important because I got to ask this question of you. The variables are going to all be gone, so you got to read this inequality and decide whether or not this is true. So if all your variables are gone, just ask yourself, is 0 bigger than or equal to 14? No, right? Like, not true. Okay, so just like anything else, this is not true. Okay, so that means there's no solution here. You would not make a graph. You would not write me any interval notation. It just means that that's not a situation where we could ever get a solution. That's not a possible inequality that we could ever solve. So not a solution there. Not true, no solution. Okay, let me run through this one real quick so you can see this. All right, so we've got 2x less than, do a little distributive property, 3 plus 2x plus 2. So I've got 2x is less than 2x plus 5. This is going to look similar to the last question where my variables are actually going to cancel out on both sides of that inequality. So I'm going to have 0 is less than 5. All right, so if all my variables cancel out, I've got kind of a special case. So is that true or false? That's true. That's always true. 0 is always smaller than 5. So no matter what we plug in for x, that's always what we're going to end up with. what do you think you would write down if that was what you ended up with?
All real numbers.
Yes, awesome. Okay, all real numbers. Does anybody know what, because I'm lazy and I don't like to write all those words out. Does anybody know what the symbol for that looks like for all real numbers if you ever want to use it? Oh, yes, I just saved you a bunch of time. You don't have to write this all out. Okay, all you got to write, the symbol for this, it's literally just a capital R with an extra stem. So just use that. That's the abbreviation. I didn't make that up. It's not something I just came up with off the top of my head. That is a legit abbreviation for all real numbers. So you're more than welcome to use that. If you guys were working with a number line, it would literally be every single number. So you would just have an arrow kind of over the top of the number line that would go left and right, because it would be any value you want to plug in for X would make that true. Does anybody know how they might write all real numbers in interval notation? Yes, it's infinity on both ends. So it would go to the left forever, so it'd go to negative infinity, and it would go to the right forever, so positive infinity. So it'd be negative infinity to infinity, both inside parentheses, and that's how you would write all real numbers in interval notation. Does anybody have any question? Okay, I can hurry through this one down here. All right, the ones at the bottom of the page, these are compound inequalities, which are really just two inequalities on the same graph. There's two different types. There's one that kind of looks like a line segment, and then there's one that looks like two different inequalities pointed away from each other on the same graph. All right, this first one, usually they're called an AND statement, and it's going to satisfy two different inequalities. And I'm going to have you guys write these with a variable in the middle. So if you got connect the dots here, you're just going to start with your smaller number, which is -2. You're going to end with your larger number that got a filled in circle, which is 3. And we're just going to put an X in the middle. Now, if you line this up correctly, the inequality symbol should always point the same direction. So the way you would write this, X is going to be greater than -2. So it would point like that. And then less than or equal to 3. So filled in circle, we've got a solid, so it's less than or equal to. Open circle, we've got a greater than there. So that's just saying X is any number between those two. In terms of an interval here, it would just be, parenthesis here, -2, that does not look like a parenthesis. And then the 3 would have a bracket. So those are pretty quick to do. So if you don't have connect the dots, which is what I have on the next question, you literally just write it as two separate inequalities. Like just pretend I gave you two separate problems. That inequality that points to the left, you're going to have X is just less than -4, less than goes to the left. For the other one, you're going to have X is greater than -2, greater than goes to the right. And you'll notice I put the variable on the left for both of those, so that way I could just point my inequality the direction the arrow went. And when you do the interval notation here, you just have two intervals. So you write an interval to represent the first one from -infinity to -4. And then also we have from -2 to positive infinity. So we just have two separate intervals that would work. Anybody have any questions? Okay. Now, let's see if you guys can solve a compound inequality. We'll go through this real quick because I know we don't have a lot of time left. Okay, how would you solve this one at the top? Like, what would you do if you've got, I've got two inequality symbols here. I've got a 6x minus 1 all over 5. Like, how would you go about solving this compound inequality that I have at the top? Yes. Okay, your ultimate goal here is going to be get the variable by itself in the middle. So I'm just going to multiply everybody by 5 here. So this is just going to be 5. In the middle, don't change any signs. I didn't multiply or divide by a negative number. It literally just cancels out the fraction. It gets rid of the 5 when you do that. Doesn't change the symbols around, doesn't change what they look like. Okay, what would you do as your next step? There you go. We're just going to add 1. Just all parts of that inequality, you're going to add 1. And again, I'm adding something, so I'm not dividing by a negative or anything. And then everybody Our goal is just to get x by itself in the middle. We're just going to divide everybody by 6. All right, so we're going to have 1 less than x less than or equal to 6. This just means x has any number between 1 and 6. On a graph here for this, I'm just, bless you, looking for like the critical numbers. So I'm going to put 1 and I'm just going to put 6. Do you have the correct circle? So should I have an open circle or closed circle at 1? What about 6? Closed. Okay, and then we're just going to play connect the dots. And you don't have to write the numbers in between. I'll know as long as you put the smaller number on the left and the bigger number on the right, we're good. The interval, super easy. So just parenthesis with the 1, bracket with the 6. And that's based on whether the circle's open or closed. Parenthesis if it's open, bracket if it's closed. And then I'm going to do one more, and otherwise we're going to run out of time. We'll save the word problems for another time. You guys can try them on your homework assignment. They're really basically what we're doing. If you've got an or statement, these should point away from each other unless they're a special case. I would literally just treat these as 2 separate problems. So I'm just going to solve each one of these just like we were doing questions on the front. We got 3x less than or equal to negative 12. Now again, don't just like, oh, I've got a negative number. Don't flip the sign just because you have a negative result. You got to think about what you're doing. Subtracting is not going to flip a sign. Dividing by a positive 3 is not going to flip a sign. So this should stay the same direction it's going here. So this would say x is less than or equal to negative 4. For the other inequality, I'm just going to subtract 1. So I got negative 2x is less than 4. Now here, to get your x alone, you do have to divide by a negative. So I do need to flip that symbol around. So that's going to become x is greater than negative 2. This is an or statement. So that means we just need to find a number that fits one or the other of these categories. So again, don't draw some elaborate number line. I'm just looking for the critical numbers. So I'm going to write a negative 4 with a closed circle, and less than goes to the left. So it should point to the left. And then maybe just, this would be like negative 3, negative 2 maybe. Open circle here, greater than goes to the right. Now, I know this is a little annoying, but for the interval, you have to write 2. So it's going to go negative infinity to negative 4 with a bracket. And then the other interval is going to be negative 2 to positive infinity. Is anybody having a question? And I'm going to stop there because we only have 2 minutes left. The word problems they're very similar to what we did